Hello, my name is Cynthia Sanchez and I'm a member of the EPC team here at Ashcraft. In this video, I'll be speaking with Dave DeLugo, the product leader for Ashcraft Temperature Products. In Dave's first video, he provided an overview of RTD and thermocouples. Today, Dave will take us through the process of ordering an Ashcraft S50 RTD and transmitter. It will cover both the ordering requirements of your instrument and a step-by-step example of how to build the part numbers for a thermowell, RTD, and transmitter. Welcome, Dave.
Happy to be here. I hope I can simplify what many people think is a complicated process.
To kick things off, let's start with the ordering requirements. What do people need to understand about the physical requirement of an RTD before placing an order?
The first thing you need to do is determine how the sensor will be mounted into the thermowell, the insertion length of the thermowell, and the diameter of the probe. The lag extension length, identified as N, is measured from the base of the head to the center of the threads on the lag extension. The insert nominal length, which is labeled LN, is measured from the base of the head to the tip of the probe. The LN can be calculated by adding the lag extension length N to the probe insertion length L. The N length and the LN length are then added to the end of the product code in millimeters. Inches are converted to millimeters by multiplying by 25.4.
Thank you, that's very helpful. Now, can you talk about the environmental factors that can influence your choice of RTD or thermocouple?
Sure. The location of your application will typically fall into one of two categories, hazardous or non-hazardous. A hazardous location is an area where there is a threat of a fire or explosion because there are flammable substances present. These locations are commonly found in oil and gas, chemical processing, pharmaceutical, and mining, for example. Once you know the location type, you will be ready to select the sensing element, which can be a single or dual RTD. Then you can select from a range of available head types that will perform best in the location of your application. Next, you will need to decide if a transmitter is needed or not. The transmitter can be mounted in the head, or a terminal block can be mounted in the head, or just flying leads in the head. The required agency approval will be based on the area classification and the method of protection, and a 3 or 5-point calibration certificate may be required.
Great, Dave. Now that we know the requirements needed for ordering, can you walk us step by step on how to create the part numbers for these products?
Yes, we will use an ISA-style datasheet, which describes the application of the probe, the transmitter, and the thermowell that will be required. We have here in front of us an ISA-style datasheet to take a look at, which will help us with the definition of the probe, the transmitter, and thermowell needed. The first section here that we're looking at is the general specifications of the application. And here we will see things like where the area classification is, what are the parameters or temperature and pressure, and what materials that this thermowell will be in. Right, so the next section of the ISA datasheet that we'll look at is the one for the temperature element itself. In this case, it is an RTD probe. The length of the probe is fit to thermowell, which is commonly done. You design the thermowell for the application and you fit the probe to the thermowell. It is a 1/4-inch diameter probe that's going to be used. And simple things like the material and the accuracy class that is required. Next is the section for the transmitter. It describes that the transmitter, what it is required, it needs a heart output and the temperature range that we're going to use it for. And then the last section defines the thermowell. This is a 3/4-inch NPT threaded thermowell with a tapered shank. It has a 10.5-inch U dimension. So with that information, we can now start to build our part number. In order to build the thermowell part number, we reference the Ashcraft datasheet for threaded thermowells. The part number would be 75W10502HT260S2XNH. The XNH is for the tag, the S is for the 316 stainless steel material for the thermowell. Determine the L, N, and LN lengths for the RTD probe. L is equal to the S which is 12 inches or 305 millimeters. N is equal to 6 inches or 153 millimeters. Ln is equal to L plus N, which is equal to 305 plus 153, which equals 458 millimeters. Our next step is to build the S50 RTD part number for this application. The part number will start with the model type, which is S50. Next is the area classification or location. So we need to review the ISA datasheet to see what the area classification requirement is. The classification requirement is explosion proof, class 1, division 2. We're going to select the code for 2, explosion proof. Next, we're going to do the sheath diameter. In this case, it's going to be a 1/4 inch as shown from the ISA datasheet, and that code is going to be T. So T will be placed in the part number. Next is the element type. This is going to be an RTD 100 ohm 3-wire. So we're going to select code 1 for a PT100 platinum RTD. Next is the accuracy class. The requirement for this was class B, so we're going to select B for class B accuracy. After that, we do the temperature range for the element. In this case, we know that the range is going to be 0 to 120 degrees. So we're going to select the A element, the thin film RTD. After that, we're going to do the wiring configuration. And the requirement was for a 3-wire RTD. So for a 3-wire RTD, we're going to select B. That's a single 3-wire RTD. Next is the sheath material, which is 316 stainless steel, code A. Now we're going to select the head type. In this case, it was defined as an aluminum screw cap head, but the area classification is explosion proof. So therefore, we're going to select the code F, which is the aluminum explosion proof screw cap head. Now we're going to do the head mounting / instrument connection. This is defined here, the element connection, as a 1/2 inch NPT. So we're going to select code 2 for a 1/2 inch NPT. Now we're going to select the cable gland. Most applications is done without. This had no requirement for that, so we're going to put a dash in place. Now we're going to determine the nominal length, which we have already calculated, which it would be 458 millimeters. This part of the code, we put an X in the coding place, and then we're going to put the LN length at the end of the code. Next, we're going to determine the lag extension needed. We're going to look at the ISA datasheet and see that the requirement is for a nipple union nipple with a length of 6 inches. The code for that would be R-J9. Now we're going to select the process connection, which is going to be a 1/2 inch NPT, and that is code R3. Now we're going to do the electrical connection. This is actually going to show that we are putting a transmitter in the head, so that we are going to select code 1. Now we're going to determine the certification that's required. So for that, we want to have an FM certification explosion proof. The next section is for calibration certificate. This particular application did not require that, so we would put in 2 dashes in the code. However, many applications do require that. Next field is for the tag. And yes, this has a tag, so we're going to put a T in there. Lastly, we're going to review the code that we made and then put the N and the LN dimensions at the end of the code. The final RTD part number for this application is now shown on the screen.
Wow, Dave, you're right. There's a lot of steps. But going through each one with you helps simplify the process. Are we done yet?
We're not quite done yet. We still need to build the transmitter part number. So to build the transmitter part number, we review the transmitter section of the ISA datasheet for the critical parameters. We see that it is loop powered. It has the RTD 3-wire input. It needs a HART output as well as the 4 to 20. And it has a temperature range that we're going to program it to 0 to 120 degrees F. So we have to select a transmitter, and we're going to select the PR Electronics PR5337D, which has HARP output, and it's going to be programmed with one sensor input, and that's going to be a 3-wire RTD. It's going to have an error signal of 22 for the high alarm. It's going to have a 4 milliamp value of 0 degrees F and a 20 milliamp value of 120 degrees F. So to build that part number, we would simply go down in our data sheet, the Ashcroft data sheet for transmitters, and build the part number. It starts with 5337D-P1. 3224 equals 0F, 20 equals 120F. The final S50 RTD assembly part numbers, it's 3 part numbers. The probe part number is shown there. Then we have a transmitter part number, and then the thermowell part number.
Thank you, Dave. This has been very helpful. Is there anything you would like to add?
Just a reminder that Ashcroft has additional videos for RTDs and thermocouples that may be of interest to our viewers.
Thank you. For more information, please visit ashcroft.com.